Good morning. Let us start. Before we go back to interlaboratory comparisons, let me thank Hans, who did what we spoke yesterday, that he took the lead in soil type of reference materials from Comar and wrote down the main parameters into this table and sent it to me. And I did some correlation analysis with this, trying to find answers to the questions that, is there any relation between uncertainty and price, or price and quantity of material? Is there relative uncertainty, absolute uncertainty, price per gram or price per whole package, etc. So I ran correlations or regressions in all different ways. And all of them were meaningless, meaning R squared close to zero, so close that there's no correlation, except this one that you see in front of you, which is relative expanded uncertainty at, let's say, K2 level. We can interpret, I think, all of them as being at the same level, and the price of the whole package. So irrespective of how many grams of material are in the package. Absolute uncertainty did not work. Price per gram also did not really have any good correlation. And here also the correlation is very weak. I forgot to mention, I took only those that are, let's say, soils or very soil-like things. For example, fly ash is a completely different thing. Yeah, it is what coming out of pipes, in factories which burn coal, for example, and so on. So that I did not include. I think it's probably not sensible. And yes, you see there's a very weak correlation, R squared 0.28, telling us that indeed smaller uncertainty, higher price, and higher uncertainty, lower price. But let me ask you like this. Do you know what is the meaning of R squared? If we say R squared is 0.28, what does this tell us about the relation between these two quantities? Yeah, let's put it very weakly correlated. We can't say that not really correlated. There is some correlation. But this number, 0.28, does that have any meaning? It does, yeah. But what might be the meaning of this 0.28? Okay, interesting. You don't know. Okay. It means, of course, like in approximation and broad terms, that 28% of the price is determined by uncertainty. And the remaining 72% of the price is determined by all other possible things. So R squared can be interpreted as how much one parameter determines the other. Yeah? Or how much, let's say, actually I said it wrongly. I should not have said it like, let me rephrase. Not determined, 28% of change in price can be accounted by change in uncertainty. What is the difference? It does not say what determines what. So correlative dependence does not mean causal dependence. Yeah? It might be causal, but not necessarily. As, for example, let me bring you this example. Yeah? When there is spring, snow starts melting. Yeah? And also increasingly you start hear birds singing. This does not mean that snow melts because birds sing. Yeah? And so the singing of the birds suddenly like melts snow. They are both determined by something else. Yeah? that is becoming warmer. Here, perhaps there might even be causal relationship, but we cannot really say. Yeah. I also did some checking whether any of these extreme points would be some extreme, so that it would be like determined only by one thing. And also I found some of the really like extreme values here. For example, here the certified value, the by far lowest certified value is 3, around 3. Oh yeah, here is a unit. Ah, no, unit is here. Yeah, okay, yeah. 3 milligrams per kilogram, by far the lowest concentration. And this happens to be this point here. So it is not in any way like extreme data point. Yeah? Then I looked at what is this, for example. It has 9.8, yeah, one of the highest relative uncertainties, and also pretty low. So this 40 is also pretty low. But then when I take the other one, which is also very similar, like let's say 40.2, also pretty low level, yeah. That one has 4.7, yeah, somewhere here, yeah. Then another one which is pretty low is 47.9, which has 5.4, which is this one. So we cannot really see that there would be like some few extremely low or high points would be like skewing this everything. We can also look at what is the highest. This was the highest. Yeah, the highest amount is this one, 200 something. This is this point here. Yeah. And this appears to be, because it also has by far the lowest uncertainty. So relative uncertainty wise, it is several times lower than the next one, 2 times roughly. So it seems that this correlation is not determined by 1 or 2 like very specific outlying points. So it does have probably some meaning. But the bottom line is there's no strong relationship between price, level of the analyte, or uncertainty in the case of lead in soil or lead in sewage sludge. In a way makes sense because, as I've already said, making CRMs is not a good business, business-wise. A lot of that is subsidized by governments or organizations, so that these prices don't necessarily reflect how much it actually costs to do all that. So that we cannot really expect a very good relation. So this is it. Any questions here? Okay. What also is actually very instructive here, you can see what are typically the relative expanded uncertainty. You see they typically range from something like, let's say, 4 to 10%. So that if somebody comes to you, some lab, and says, yeah, our lab has relative expanded uncertainty determining traces of lead, 1% relative, you should be very skeptical, because these are gurus who have made these measurements. All right, so let us continue here. This was the last slide yesterday. I explained consensus and independent reference values. And now, before I continue, any questions about this? as I explained, these independent values typically are determined by gurus, meaning they are of high reliability. These are of low reliability. Usually, if there is sufficient number of participants, consensus values are not so bad. So here is a very typical example that you can find. Here you see this gray area is the reference value range. It's trace lead in water is the measurement. And it is 60, let's say the average value is something like 62.3 nanomoles per liter. Yeah, this is what the reference value is with uncertainty. This is this gray area. And this is independent reference value determined by gurus, independent of the labs. And these are now all the labs that have participated. You see that the average of the labs probably pretty well agrees with what is this gray area. Of course, what you also find, let me maybe also draw your attention to this, that many of those labs are catastrophically off. Yeah, let's say most of the labs that are in this rectangle are catastrophically off. Most who are in this rectangle are catastrophically off. And if you read this small box, you see that there are 18 values which are still up here, which are so off that they did not fit into the graph. And please note, these labs that participated here are not student labs or school children doing their first steps in chemical analysis. These are professional laboratories that have customers, take money for their analysis. This IMEP used to be run by this same Institute for the Reference Materials and Measurements. It now does not run anymore. International Measurement Evaluation Program. And that was a series of proficiency tests aiming first of all at the Eastern European labs back in the times when the Eastern European countries were not yet parts of the EU. So then this was launched. Yeah. Ran in the 90s and then also in the beginning of. Okay. And these IMEP reports are full of graphs like this. So here, consensus value would essentially work pretty much the same as independent reference, but not here. This is one of those where it's not the case. So you see the vast majority of labs underestimate the amount. And again, please note there are 11 more down there which are so off, they are somewhere here, yeah, so off that they did not fit really the graph. This is, of course, now a tricky case because this is mercury. Yeah, very low levels, and mercury is very, very, very nasty. And losses with mercury analysis are very common because it sticks to all the walls of all the vessels and tubings and so on and so on. And this is now the reference range, again, with determined by gurus, and most of the labs have not really managed to do. And what makes also this like disturbing is that most labs underestimate, which means that when they will be analyzing mercury in some like drinking water or whatever other material, they might get underestimated results. They might say, yes, this is safe. Yeah, not enough, not much mercury in it. Yeah, please go ahead and then drink it. Yeah. Which is the bad type of mistake because people might get poisoned. Luckily, of course, all the allowed levels of mercury specifically are always very cautious, meaning they're already very low in the sense that it's very well known it's really, really a toxic and nasty element. Mercury is, I think, the most toxic element in terms of allowed limits in drinking water or in any. Okay, so here certainly it's a good idea to have independent reference value. And here is now a general scheme. Consensus values come from participant results. Independent values can come from either formulation or from expert. Also, let me just repeat that most of the time in proficiency tests, people or organizers use consensus values. These independent values are not common, or are less common. Let's put it that way. Now, before I continue, maybe you have questions. Okay, if not, then let's go ahead. Now, establishing reference values and uncertainties are actually fairly similar to certified reference materials if they are the independent reference values. So, formulation, you can use weighing data, mix together pure compounds, get very accurate reference values quite cheaply. And again, of course, you have to prepare large amount of material, and homogenization very important. And again, you only can use this with simple methods. So the same talk as we already had. And here is the formula for calculating the standard uncertainty. And you recognize it's essentially the same as we had with the certified reference. Formulation, meaning all these weighing, etc. data, variability between bottles, and stability. There's nothing really much more to explain. And now, if it is expert labs, it is again essentially the same thing as producing CRMs. These are guru laboratories, highly reliable reference values can be obtained, can be applied to all sample types. But drawbacks, of course, are takes time, is expensive, and you have to have such labs who are willing to participate. And this is exactly the same formula now as we had with certified reference materials. I don't see much to explain here. And this question I actually already asked. We perhaps ask again, what is the difference between making interlab comparison samples and CRMs? Although I already asked it yesterday. Yeah, you don't need long-term stability. The stability is just, let's say, the 1 month or something like that is sufficient. Now, consensus values. This is new, this we haven't looked at. The most common, usually not high quality, and usually no rigorous uncertainty estimates. And I will leave this for the future. So I'm not going to explain at the moment. We will go through these all steps, and then we will see how the consensus values from participant results are found, because they are found after participants have made the analysis. We will look at this later. Now, the next important step, inviting the participants, and this seems to be like something trivial, but not so trivial, as I will demonstrate. So most of the time, proficiency tests are open to any participants who wish to participate. Because quite a number of them are run as commercial services. And organizing intercomparisons is better business than making CRMs. So organizing interlaboratory comparisons is easier to make it profitably than making. And of course, since there's a lot of constant cost or fixed cost in organizing any round, then the more participants, the better. So those professional organizations or companies who organize proficiency tests, they're interested in large numbers of participants. So oftentimes it's 100 or more, several hundreds of participants in one round. But sometimes it's also limited. Sometimes it's specifically some laboratory organization organizes the proficiency test only for its own members. For example, the Eurofins laboratory system that runs here in Europe, it's a big number of laboratories all over Europe. They can organize just for their members, their member laboratories, then it will not be. And inviting means that quite a bit of information needs to be given when you invite laboratories. The organizer has to be identified who it really is, the type and objective, meaning what type of samples and what types of analytes. Then more detailed information about samples. Maybe there can be, for example, storage or handling requirements, sample preparation, etc. Why is all that important? It may turn out that some labs don't have all the facilities that are needed for doing those things, and then they cannot participate. And it's fair to say this immediately when inviting. Otherwise, the participant maybe already has paid fee and received the sample, and then it turns out that the participant actually does not have the possibility to do that. Then, if there's fee, that fee has to be also mentioned, of course. To what extent the results will be public? In most commercial proficiency tests, nothing will be public, meaning the reports will be only sent to the participants. Participants will be coded, just numbers, not labs won't be identified, and every participant will simply get that, okay, your lab number is 37, so report, and you will find your results under number 37, so that you don't get any information. But sometimes there's more information, and this has to be clearly said. And also something about the preliminary schedule, by when the registration needs to be done, approximate time until sample delivery, and so on. I have the possibility of showing you. Now from this link that you had in the slide, you can see how we did it in this ESTOIL edible oil intercomparison. This is one that was organized for some years here at Tartu, and we did it together with Verol Tehased, which now is called Scanola Baltic. Sells rapeseed oil. You might have even encountered that term. But back then it was called Verol, this company. And this is edible oil intercomparison, and this is our invitation letter. Here are all the parameters. What kind of rapeseed oil is. In some cases it's refined, in most cases actually. In one case it's crude. With one parameter it has antioxidant added. We can look at that later on. What is the... Then it is clearly said here that samples are prepared by Verol. So we did not prepare samples. Verol has the oil industry, and it was much easier to do that. They will fill all those bottles. And we also declare that we adhere to this ISO guide 74.1, which now this guide is not valid anymore. Now it's ISO 17043, which I think I mentioned yesterday also. We are not, and we were not accredited according to that. but we simply adhere to participants. And data treatment comes way. We also give here the information that the report will be made public and participants will be identified. So it will be publicly known which labs participated, but they will be in random order, so lab numbers and participant identities cannot be connected to. We see that, okay, this lab participated, but, or I mean, everybody can see that this lab participated, but nobody can see which were the results of this. This is quite rare that labs can be traced to the results, and the labs almost never really want it. So if you say that, yes, we will make it public and we will explicitly say what results you got publicly, then most labs will not want to participate. You lose your participants. This was the first year when we charged money. In the first rounds of this, we did it free of charge to attract more people. If you are interested, then here, it still works, this address. I think actually in Moodle we have the address now has changed, but I guess there might be forward. But in Moodle I think you have the address where you can find all the reports of all those STOIs if you are interested by any. This is the registration deadline, and this is the approximate timeline of this event. And of course, it is here explicitly said who are the organizers. Here is a registration form. Being all the information, which parameters they want to determine, because not every lab determines all these things. Some determine only some of the parameters. I will later show you the report also, and you will see that actually, I think very few labs determine everything. I think even Verol did not determine all of it. Okay, so this is a kind of a letter that should be sent. Yeah. Why is it not free of charge? Then I have somehow completely failed to convey the right information. So if it is a proficiency test, then participants pay to organizer, because organizer is the one who bears all the costs of preparing samples and sending and making the report and so on. But the organizer pays to gurus, expert labs, if there is independent reference value. Then the organizer pays. But participants pay themselves to the organizer. Did anybody else have the same confusion? Okay. So most of the time, as I'm also writing here, it's not usually free of charge. So the fact that we did it free of charge for the first few years was actually like exception. This is not really common. Those IMAP things were also free of charge, but that was a European Commission big project, which was used for funding those. But since organizer has significant costs in organizing, then organizer has to get money from somewhere, meaning typically from participants. The costs that you saw there are trivial, they're tiny, small, and absolutely did not cover the actual cost of running this thing, so that the fees should be much higher. And this is partly the reason why we are not doing that anymore now. It's quite expensive, somebody has to do it. Does not give us so much added value actually for all these our activities. we started doing it, first of all, to have the experience, and so that, for example, I am now here able to teach you these things, because we've done and we know what are the problems and how this is done. But just running it over and over again, we might do that again in some future if some very enthusiastic person comes up, but right now we are not right now regularly organizing interlab competitions. Sometimes we still do that like in irregular way, but we don't run any regular scheme. All right, so inviting. Then sending samples. Again, seems trivial, but maybe not so trivial as one might see. Must be securely packed so that they don't get broken. It is very important to communicate with participants. Yeah. And organizer has to have spare samples. Together with samples, we typically send something that is called sample description. Yeah. You see, okay, these are the samples. For which parameters are used? Refined rapeseed oil or crude rapeseed oil or refined rapeseed oil with an antioxidant? No. Then description, the dark glass bottles. Each bottle has 100 milliliters of oil and so on and so on. Yeah. How they should be stored, how they should be opened. Yeah. Prior to the using, the bottle should be kept at room temperature for temperature. The bottle should be carefully shaken before analysis. After opening the bottle, sample should be used during a short time period. Yeah. And then there's a special situation with peroxide value. I will come to that later on when I will explain you the report, because then it is easier to explain it there. Peroxides form in oils, and peroxide value is an unstable parameter. So we have reason to believe that that value might change in time, even in unopened bottle. For that reason, we limit the time by when they have to do that analysis so that they would not wait too long. This is all about the sample description. And then another thing is sample receipt form. Why is this one needed? This is the one whereby participants tell us that, yes, we've received the samples, yes, they are okay, or no, they are broken, no, please send new ones. So this is, please send by email or by fax. Yeah, at that time, fax machines were still in use, but now, of course, we would. Now, of course, all this would be web forms, not like any kind of files at all. Yeah, laboratory, yeah, executive charge. Yeah. And they can either write that they received in good order, or that they have reason to believe that it's not in good order, like bottle is broken or whatever. Yeah. Then they will let us know, and we will immediately send new stuff. Okay. Handling samples. Again, for example, if it is written that you must shake, then you really must shake. If it's written that you must store in cold and dark place, okay, you must do that. So it is essentially the same as with CRMs. You should handle the samples exactly as is prescribed by the organizer. And for intrinsically unstable parameters, there might be some reference date or reference range of days when you have to do the analysis. And this is now again, in some sense, an advantage against certified reference materials. Certified reference material parameter is so unstable you cannot. But here you can. Even with less stable parameters, interlab comparison still can take place. And this approach is, of course, based on the assumption that all the bottles age at about approximately the same rate, either increases or decreases with the same. And now it is performing the analysis by the participants. And again, it might seem that here there's nothing to explain. Yeah, well, chemical analysis. Yeah, there are some things. If it is a proficiency test, then what that means is that labs should use the same method and carry out the analysis with the same level of care that they would do in the routine work. Because only in this case the PT really evaluates how the lab routinely normally performs. And the best way would be that the person who does the analysis does not know that this is interlaboratory comparison. So in big labs, this can sometimes be organized in such a way. So all the kinds of samples come in, they are labeled with some like labeling system in the lab, and then they are sent to the analyzer. And then for the analyzer, they adjust some samples with just some codes. The analyzer has no idea that these are customer samples and this is interlab comparison samples. And these are again. That's the best way. Because then it really is like fair. Yeah? Of course, I haven't worked myself in such routine labs, but I've still heard some things. Yeah, so that very often what actually happens in routine laboratories is that when the interlaboratory comparison sample comes in, then they literally jump and start, now we have to calibrate everything, clean everything, maintain all the instruments, do this and that, so that everything would be as good. It's not really okay. Yeah, but of course, it's like difficult to check, and that nobody can really verify or avoid that. But ideally, this is how it is. In some cases, this is not doable because sometimes in more complex situations, some specific nuances of sample preparation, for example, might be prescribed, which means that this might not be possible to handle as a routine sample because the person who is doing the analysis must know this thing. So it can be, for example, some kind of milling beforehand, or maybe drying in an oven for something. So there can be all kinds of different things that might be required. And then, yes, sadly, it's not possible. But in most cases. And then the next thing is reporting the results. This is usually done with a results report form, which nowadays typically is a web form. You don't send any papers, of course, anywhere, not even emails. But back then, when we did it, we had it like this. Yeah. It was a Word file where they could fill in all the data. Let us now see what this is. By the way, if any of you in the future ends up organizing something, and this can happen, by the way, if you happen to work in some, like, as I said, CRL, community reference laboratory somewhere here in Europe, it might be your task or the task of the laboratory to organize intercomparisons for the sector where you are working. So if you end up doing that, you are more than welcome to use all these materials. And like, how would I put it there? Copy them or do whatever you like with them. Use them as models. But most likely, of course, in the place where you end up, they have their own models and things, and they don't want. But in any case, you are allowed. So here is, first of all, the deadline. Yeah, the deadline was also mentioned in the invitation. Yeah, May 8th was the deadline for submitting the results, then all the data, and then it comes, all these parameters. Of course, every lab only fills in the parameters which they actually determine. They need to give the number of bottles were numbered. Then, of course, the measured value, obviously. Why we have here this comment, very interesting. In the first rounds when we started organizing this, then sometimes people presented several values for the same parameter, apparently hoping that at least one of them will hit the consensus, and that then they can say, so look, our value agrees with the consensus. We didn't want that. In those cases, we sent back and said, no, you have to submit only one value. And then we put this comment here so that this would be avoided. Then they have to give uncertainty, but many of them don't give actually uncertainties. We will see later on what they did, and uncertainties are often very interesting. Let me put it that way. So that actually we do not, if lab does not give uncertainty, we can still manage. We can still do the data treatment, but we cannot then calculate all parameters. But the lab still gets information how bad or how good they are. Okay, then the coverage factor and confidence level. Okay, this is typically K2 what they present. And then what is very important, unit. We prescribe unit. We ask to present in this unit. We do not do unit conversion. This is pretty important. It's very useful and important to organize it in such a way that we do not manipulate your data in any way. This is what you presented. This is what we don't give them freedom in choosing the unit. The units, of course, have been put here such that all these oil laboratories typically use these units. So they are not some our inventions. They are actually the standard of the industry. So nothing special. And there are also some additional explanations. Like ppm is identical to milligram per kilogram. Then free fatty acid content typically is expressed as oleic acid content. Why this is important is that the molecular mass of the acid plays a role, and different chain length acids have different molecular weights. So you use different acid as a standard, you get different free fatty acid content. And then saponification value is defined either as sodium or as potassium hydroxide in milligrams required to saponify 1 gram of something. Saponification value essentially measures average molecular weight of the fat or oil. It can be expressed typically in two ways, either sodium hydroxide or potassium hydroxide. It's not important which one was used, and you can always calculate from one to the other. But again, it's the molecular mass that is at play here. Potassium hydroxide has bigger molecular mass, so there's a bigger number if you use potassium. So if some present in sodium hydroxide and some with potassium hydroxide, then we absolutely cannot compare. So this is why I'm presenting these things, that small nuances, which if you overlook, you get complete nonsense. For example, if you don't pay attention which hydroxide they use, you automatically get big mismatch because actually the units are different. You are comparing in different units. Then we explicitly ask them to give peroxide value date. One more thing here, method also. That's actually not very important for us, except in one case. I think I did not mention that. That was also in the invitation. For moisture content, we require that it's the Karl Fischer titration, not loss on heating. Loss on heating is notoriously unreliable in fats and oils. If they presented data on loss on heating, that's fine. We still take their data into account, but we don't use their data for consensus value. consensus value is only derived from Karl. Again, a very specific thing, yeah, that here it's important. Most of the time people filled here just some kind of ISO this or DIN or whatever, some standard numbers, and according to which standard methods they use. And except this moisture content, they are not really important for us for data. Yeah? Then peroxide value analysis date and something about sample preparation procedure, which also is purely informative and not really, was not really very. Okay, so this is how results are presented. As I said, nowadays, this would of course be done with some web form, yeah, not with some. All right, let me, before we go to the data analysis, I stop for a moment. Any questions, maybe? Luis?
Okay, I have two questions. The first one is related to accreditation. Like if an accredited lab participates in an interlaboratory comparison, it needs kind of for this accreditation 17025, it's accredited for the method they are using, right? So in this case, they will need to participate in this comparison with that exactly method to be in compliance. So the labs must be like in search of interlaboratory comparisons that are like leaded to that specific method that they can use, because if they are they participate in any other that they don't really need to use that method, then they cannot comply. So is this any kind of problem in laboratories to search a specific comparison that in which they can comply with the accreditation they have?
This is a very clever question. You have pinpointed a very important thing, and yes, it is a worry. If you do some very general thing, again, like elements in drinking water, then you find many intercomparisons. Just pick and participate. But when you do something more, or let's put it, less mainstream, yes, you might have big difficulties. And yes, you have to participate with that method. So that I said that moisture in oil, we calculate the consensus values only taking into account the Karl Fischer titration results. But if a lab is accredited, or if the method within the accreditation scope of the lab is loss on drying, then they should participate with loss on drying in order to demonstrate to the accreditor that, yes, we have participated in this intercomparison. So that, yes, depending on what are the methods within your accreditation scope, and by method, what I mean here is what matrix, what analytes, and then what technique, you have to find something which matches those things. Sometimes accreditors also are, like, let's say, flexible to some extent. So, for example, if you think of a good, okay, let's put it like trace elements in fish. Yeah, you do trace elements in fish in your laboratory, okay, but there's no fish intercomparison, but there's chicken, trace element in chicken. Then that's probably okay. Probably the accreditor will say, yeah, that's good enough. Yeah, okay, there was no fish intercomparison. But analytes have to be the same. And also, if you have that, for example, you have that accreditation with ICP OES, yeah, but you are participating with ICP-MS in the intercomparison. Also, that's not really okay. Yeah? So yes, you have to do the same way. And yes, it's sometimes difficult. We have had those problems frequently because we do occasionally very strange things. Yeah, and I mean strange in the sense that not mainstream. And then, what's your other question? Did I answer this one?
Yes. I was thinking about that because I think about it commercially, like things that are selling more maybe are going to be more mainstream.
Absolutely. This is exactly how it is. Again, drinking water, just pick it, yeah, whatever you want. But if it's, let's say, I don't know, zirconium in wood chips, for example, then you would probably have hard finding anything at all.
And my other question was in terms of the sample preparation. Like, for example, in this company that was prepared bottles of oil. In this case, is when they do like a professional determination for establishing the reference value of the interlaboratory comparison, it is also made just by one lab, or it is also made like by several labs, so they can avoid a little bit of bias in the establishing and the reference value.
Can be done both ways, but usually for interlaboratory comparisons or proficiency tests, if independent reference values are used, there are not as many participating guru labs as with certified reference materials, again, to keep costs down. So I'm not so familiar actually with, but I don't think anybody would hire 12 labs to get reference values for a round of proficiency test. Probably 1 or 2 or 3. I don't think it's more. But as I said, most of the time, all of those organizers who do it commercially because of costs and also time, they use participant. So the intercomparisons with independent reference values are not so often done, except again when sample can be formulated, then it's completely different matter. Then it's pretty cheap to do. Okay, now Christian has a question. Did you also have challenges with the number of decimal number rounding off or the results submitted by the participants? No, we did not really have those challenges. We don't prescribe how many decimals after the comma they have to give. If they give too many, that does not cause any problems for us in the data treatment. If they give too few, they simply have the risk that, yes, just because of rounding, they will be off. But again, this is not really so much our problem. It is their problem. Also, the agreement of the value and uncertainty in terms of digits. Actually, we don't check that. Yes, it is simply incorrect to present like value with many more digits than uncertainty. But again, since that does not cause any problems in our data analysis, we haven't really done anything against it. Yeah, again, yeah, it wasn't really a problem. It has not really been a problem at all. When I will show you the report, you will see that yes, labs present occasionally with quite different number of digits. Yeah. Sarah, yeah, please take the microphone. We cannot. This is just, we are operating in good faith. If the lab, if we send the first sample and the lab reports back, it's broken, send another one. But in fact, it wasn't broken. We have no way of checking. We will simply send another one. In principle, repetition is allowed. You see, it's 100 milliliters of oil. They have actually a lot of oil. Repetition is possible just with this one bottle. They don't even need the second one. No? So they can do many replicas, and this is actually what we would encourage. We are absolutely not against that. But eventually they have to submit one result only. So it is not really, suppose they use up the first bottle completely and then realize, everything's wrong. Oh boy, how bad. Yeah, we've done it completely wrong. What shall we do? Let's ask a new one. Yeah. And they ask a new, and we will send the new one if they recognize their own mistake and now did it right with the second one. Then I don't see a problem. But of course, they cannot do it so that they first report, yes, we've received the bottle, very nice, yeah, good, it's not broken. And then they suddenly send us, no, bottle is broken, please send the new. This is what they cannot do. They then have to immediately, okay, we would like more bottles. Yeah, no, the bottles were broken, please, new ones. You cannot do that afterwards. You see what I mean? They have to send back the bottle receipt form immediately. But that has not really been a problem at all. We occasionally had to send more bottles. think in some rounds we did not send any more bottles, or everything was received as required. In some cases, we maybe sent one or two, but in any case, we did not have that problem. Did I answer you? Okay. Good. Then let's look at data analysis. This is now again on organizer who has to do all that. And data analysis essentially means the following, that we need to find out how competent are the labs, meaning we have to somehow get some kinds of estimates of true values or best estimates of true values, meaning the reference values, and somehow evaluate how much off are the participants from the reference. And for that, there are different scores or parameters that can be used. There are more than what I'm presenting here, but I would say the three main ones are zeta score, EN number, and Z-score. And occasionally also what can be done is comparison with legal requirements and documents. That's not so common, but still occasionally it's done, but usually it's done in addition to one of those scores. The first four of these, first three of these, this is why they are ordered in such a bizarre way. These three require independent reference value. The last one does not. For this reason, the Z-score approach is the most common. Yeah? But let us look one by one. So zeta score, we already looked at when we looked at certified reference materials and checking your method. So I think I probably don't need to explain anything anymore here. Everybody happy? Yeah. Okay. And zeta score is in a way, it's my favorite actually. Then EN number. EN number is quite often used when metrology institutes or really professional metrology organizations run their intercomparisons. Those are intercomparisons, again, that are used for example, setting up or checking the whole measurement infrastructure or establishing traceability of high-level international standards to each other, etc., etc. And the formula of EN number, as you see, is very similar, with the only change or difference that these U's are expanded uncertain. So in zeta score, these U's were combined standard uncertain, but here they are expanded uncertain. Bizarrely enough, this standard does not say what has to be the coverage factor. So that if I present at K2 level, the other person presents at K3 level maybe, then sort of still all works, which I find strange. But it in reality is not such a big problem, because almost everybody, almost universally uses K2 or 95% coverage, which is pretty much the same thing. If it's some high-level measurement, then usually number of replicates, etc., is and all the let me ask you one thing. Let's assume these uncertainties are K2 uncertainties. What then is the relation between zeta and EN if the uncertainties are K2 uncertain? What is the relation between zeta and EN? Exactly. Zeta score is 2 times higher than EN score. because these numbers here are 2 times bigger than the combined standard uncertainty. So that if you look at this, here the threshold of good values is 2 in zeta score, then it's not surprising that here it's 1. So that EN number and zeta score actually do a very similar thing. But EN number has the difference that this warning band or warning interval or warning range is missing. Anything above 1 is unacceptable, meaning which in zeta score wise would correspond to zeta 2. So this makes EN score interpretation somewhat stricter. You don't have this so warning, yeah, unclear. This does not exist. Yeah, it's either good or bad. Yeah, either of these. Now, zeta score and EN number. What makes them good? First of all, it takes into account the uncertainty of the laboratories. And this is pretty important thing. The bigger is the uncertainty that you report with your result, the smaller your zeta and EN will be, because uncertainty is in denominator. And indeed, some people might run some semi-quantitative analysis, which intrinsically has big uncertainty, and all that is then accounted. So that this is a metrologically sound approach. At the same time, it also has, both of them also have drawbacks. First of all, you need an independent reference value. Otherwise, you cannot do. And secondly, which also is important, it does not, or zeta or EN do not give you any information about how this lab performs against some requirements by legislation. So legislation, for example, might say that, okay, this must not be off from reference value by more than 10%. But if lab has declared high uncertainty, the zeta score or EN score is very good, yeah, while actually the lab's result might be not suitable for making analysis in the framework of some legislation. So that this just does not give that kind of information at all. You may remember those of you who were in the winter school, which means that the large majority of you, yeah, each student, when we had the discussion about your intercomparison that you did there, this solid oxygen intercomparison, then Professor Randon brought this up. Okay, yeah, but you cannot really increase uncertainty as much as you like, because then the customers will not be happy. And this is fully true. Yeah, you as lab are allowed to quote as big uncertainty as you like, as long as your customers are happy with so uncertain results. And you absolutely must not do such a thing that for intercomparison you specifically increase your uncertainty to get low EN score, but then for customers you show this kind of uncertainty. This would be simply a fraud. Yeah? This is something you absolutely must do. And then a minor drawback also is here, that the EN number, the coverage factor, is not defined. But again, as I said, in reality, it's not really a big problem, because almost everybody uses K2. All right, now the next thing is comparison to legal requirements or requirements of standards. And this is actually very relevant, because lots of the measurements are done in with the purpose of assessing compliance with some legal requirements, standards, etc. Such as, for example, drinking water, yeah, how much trace elements are there in drinking water? Yeah? And if the standard or legislation has some requirements, how big or small uncertainty must be, or how much off you can be from some reference value, then this can be used. But of course, it has a number of prerequisites. The first one, which is the most serious one actually, which usually is not met, is that the legislation must specify such criteria. In most cases, legislation does not do that. For example, if the legislation says, okay, there's this toxicants, list of toxicants, the maximum permissible limits in certain products, that legislation usually does not say how accurate must the analysis method be or how much off can it be from the reference. Then you just cannot do that. Then, of course, the intercomparison has to be run the same way that it is really comparable to the requirements of the legislation. It's not like the same matrix, the same analytes, and so on. Yeah? So it must correspond to what the legislation says. And finally, you typically need independent reference value. So you typically need high quality reference value. Otherwise, you cannot really say that the participants was off from the reference value. If it's a shaky consensus value, then it's not really. You might say that, hey, wait a minute, but we just saw this very nice intercomparison with lots of participants and the consensus value very well matching with independent reference. Yeah, this is true. If there are 100 participants, this is often the case. But sometimes in one round of intercomparison, you might have just 15 participants, for example. Then it's not so clear at all whether the consensus value will be a good match with independent reference. Okay. Finally, the most widely used characteristic is the z-score. Here, we do not need independent reference value. Consensus value is fully okay. It is then calculated so that from lab result, the consensus value is subtracted and divided by something called target standard deviation. So that you see that participant uncertainty is not required and is not taken into account. This is an interesting thing. Targets, so consensus value in the, let's say in the simplest case, consensus value is simply the average of all the participants. But I will come to that. It's nuanced. It's it's oftentimes not as simple as what I just said. And target standard deviation in the simplest case is just the standard deviation of the participants. But again, this is more nuanced, not as simple. And the meaning, the true, like the rigorous meaning of the target standard deviation is this. It is the standard deviation that expresses the expected variance between participants. And I'll come to that, why I'm making distinction here. And why consensus value oftentimes is not just the average and target standard deviation, not just standard deviation. Yeah. And these are pretty important things. Interpretation of z-scores is exactly the same as zeta scores. It also has this 3-level interpretation, so good, warning, and unacceptable. There's not much to explain. Pros and cons. Cheapest, the simplest. Yeah. Organizer can escape from any, like organizing any separate measurements of the parameters. Also, the organizer does not need to know beforehand what the analyte concentrations are. The organizer needs to know some ranges, because that should be like given already beforehand. But it can be very vague range. Yeah? You can say, for example, okay, lead concentration here is between 1 and 20 milligram per kilogram. It's perfectly okay. Yeah, 20 times difference. So you can give essentially orders of magnitude adjustment. Okay? And you can almost universally use it. No independent reference value is needed. But then, of course, it also has cons. First of all, participant uncertainties are not taken into account. And this means that if a participant is doing like something, let's put it semi-quantitative analysis, with some very simple express method, which have high uncertainty, yeah, then that participant might often find him or herself being off, and the z-score too high or too low. Secondly, it does not work well with few participants. This is maybe even the most important problem. Somebody asked yesterday that, okay, what is the minimum number of participants? And then I explained that if it's independent, if independent reference value is available, you can run intercomparison with just one participant if you wish, or with two. That doesn't really matter. It matters cost-wise, business-wise, but not like data analysis-wise. But if it is consensus value and z-score is used, then I would say that below 10 participants for the parameter, not just overall participants, but for the same parameter, below 10 is already somewhat uneasy. But it can be lower than that. We will get to the Estoil report, and then you will see that sometimes there are few. Now I see Christian is asking a question. Let's see. Is it wrong to use z-score even if you have independent reference value? Not really. Yeah, you can additionally use also z-score. Not problem at all. Suppose you want to proceed with the round but had few participants and most labs did not submit uncertainty. Yes, yeah, you can. In principle, EN numbers and zeta scores can also be calculated if the lab did not submit uncertainty. You can then assign to them uncertainty 0. But this, of course, will automatically increase their zeta scores. Now, if this trick is used, then this has to be announced like beforehand. Otherwise, it's not fair. Yeah. The next problem or possible problem is that participants can be biased. And here I just some minutes ago showed you an example of this Mercury analysis where participants were downward biased, yeah, very, very strongly. And this, of course, again, is serious. Yeah? And like zeta and EN scores, these scores do not give any direct information for whether it complies with legislation, etc. So that information is simply not. Now I have some interesting examples, but before I show them, please ask questions. Let me also say that if I said here that nuances and nuances, we will do a calculation. You all will be doing data treatment of an interlaboratory comparison. Then you will see what that is. So all will get that experience. This reminds me that please bring your PCs next time. And this reminds me that next time is Friday, yeah, which I said yesterday, but let me just remind you that Friday, I think it was 12 in this same room. And now this Friday we have the lecture. Next Friday, not yet clear. I will let you. But this Friday, bring your PCs because hopefully we can, by that time, reach the state that we can do this data treatment. All right, but now, any questions before we move to examples? Maitane?
Sorry, but in our like the comparison requirements, like the threshold, what does the comparison specify? I didn't get that part.
Okay, let me bring you such an example. Okay, yeah. Let's assume that legislation says that, okay, lead in drinking water, the concentration, the maximum permissible concentration is, let's say, 10 milligrams per kilogram or per liter of water. And the trueness of the lab result, meaning average value of replicate measurements, must be at this level of 10 milligrams per kilogram, must not be off from reference value by more than 10%. Meaning, if you analyze 10 milligram per kilogram lead in water, your average of many replicates must be between 9 and 11 milligrams per kilogram. This is what legislation says. Yeah. But neither z-score nor EN nor zeta checks that. You might be more off, but maybe all participants have, like, target standard is pretty big, you are much more off, you have, let's say that the organizer made sample which is close to 10, yeah, close to, okay, you got 8.5, you are more off than 10%, but the target standard deviation is big, so your z-score is 1.3, oh, you are good, yeah, very good, you passed, yeah. So, let's say z-score wise, oh, you did well. But legislation-wise, legislation actually, if legislator looks at, no, you did not do well. Yeah? You're too much off. Was that, yeah. What is done sometimes is that either this EN or zeta or z-score is used as primary, like evaluated, but additionally legislation things are also invoked, and laboratories are then also like evaluated against how they comply with legislation. But that is not so often done. Yeah. Okay, yeah. Komal, you wanted to ask?
That's the same thing. Like, they do not specify how off you are from the how you can like present the results to you. And this is the primary thing, and then run an extra.
This is what is often done. Yeah. But this, you see, this is, there's one more trick which I did not actually explain well. I don't have it written. Oh, okay. The trick is that different countries might have different legislation, meaning in one country you are allowed to be 10% off, maybe in another country you are allowed to be 20%. So that it's also like it invites another difficulty. True, for example, if we take this drinking water, throughout European Union, the requirement is the same, which is 500 million, not 500, let's say more than 400 million people, which is a big thing. But if somebody from Morocco, Turkey, or Israel, etc., Norway participants, they might have different legislation. And these big inter-comparisons with hundreds of participants are typically very international, so there are people from many countries. Even our S-TOIL was quite international, as you will see later on, yeah, from which countries.
I have another question. This data analysis with z-score that does not include uncertainty, is it possible that it can be linked like laboratories with like routine laboratories that are not experts doing their job or something like that, like some kind of clinical laboratory that has like blood samples and they just like simple analysis that are done automatically. That's why they don't need to like calculate uncertainties or things like that, or there's not something that happens, or also happens with accredited labs with high standards, more specific methods.
Luis, I did not understand your question.
Like I mean, like this z-score means that the laboratory in the comparison does not have to calculate uncertainty. They just present the result, and then they have this data analysis. But I imagine that very proficient lab, they will have the possibility or the knowledge to calculate this uncertainty of their method. Some other kind of labs that are just like routing labs where like they don't have so specified methods or not so much budget. Is this Z-score something that is lead to those kind of labs that are not such experts in doing a specific analysis or trace analysis, just like routing analysis, or is something that has nothing to do with that?
I don't fully understand.
Like,
what exactly is it that you're asking? Let me just say that whether a lab has presented an uncertainty or not, or how big it is, just does not influence the Z-score at all. The uncertainty simply does not come into the formula. So if there's one expert lab who is very good at calculating uncertainty, has very good uncertainty estimate, and then there's another lab which is not really good at all, maybe doesn't know anything about uncertainty, they will be treated the same way. Yeah? So the expert lab with having a good uncertainty evaluation ability is not any like advantage in terms of disease.
I was thinking just like this type of interlaboratory comparisons, data analysis could be just done for certain group of labs, and then others with another kind of analysis are for other kind of labs. But in general, they participate in all kind of comparisons. There is no such difference. Right?
You usually not. We do something extra. I will show you later on, or we did. I mean, something extra in our S-TOIL comparisons, and I will show you later on what exactly we did. Yeah? But generally, yes, if it is Z-score based intercomparison, anybody typically can participate with any methods and with any knowledge or not knowledge about measurement uncertainty.
Not really necessary to have good metrological knowledge to participate in these comparisons.
If it is fully open comparison, and if you are willing to pay the money, there's absolutely no requirements other than that. You pay, you receive the sample, whatever you do with the sample, you send back the result, and so on. And that's it, yeah. It's like, and find some. Okay, I think a good analogy is that I think most of you did the IELTS test, or some of you did TOEFL test for coming here. So I think you all agree that you can be as bad as you like in English. You are still allowed to walk into this, or I don't know how you do that actually, maybe on internet. As soon as you pay the money, it's fine. And if you don't know a word of English, you will simply get score 0, close to 0, but the testing organization will be just as happy because they've got the money, and yeah, you've got evaluated that you are very poor. Do you see? Yeah, so you are allowed to be very bad when you go to the IELTS test. I don't think anybody will be angry with you there. You will simply get a very low score, and that's it. Yeah, that doesn't apply to any of you, because otherwise you wouldn't be sitting here at all. But in principle, yeah, you are allowed to get poor. Likewise, in principle, in this university, we are saying, yes, there will be exam, please study. But in principle, you're not obliged to. If you fail all these courses, you will simply fall out of the program. Very sad, but that's it, yeah. So, I mean, there is no punishment of any kind except that you will simply not get your degree. So here also, that there's no any other punishment than simply very poor Z-score. Yeah? So that, yes, you can actually do it analysis in your home, yeah, by some very, very primitive methods, and still participate. Okay, now let's see some examples. I think I will not manage to finish with all the examples, but we will then continue on Friday. This is now the same graph that I already showed you. And now the consensus value would be somewhere here. I did not have the numerical data, so I could not really calculate. And we see that most labs are actually seriously off from the reference value. In a very simplified way, we can say that if a participant's uncertainty range overlaps with reference range, we could say, okay, yeah, it's more or less okay. But you see, there are numerous participants where there's absolutely no overlap between the participant uncertainty range and the reference range. Yeah, like for example, let's see. Like these two participants here think that they are very good. They have declared very small uncertainties, but they actually not good at all. Yeah. This participant here thinks that he or she is really very good, but they're actually very bad. Yeah. But roughly 64% of these scores are okay. So if we calculate against this consensus value, the z-score, then those are, so that z-scores would be much too optimistic. Moreover, it is well possible, I did, again, I haven't run the calculation in a rigorous way, but it's well possible that, for example, these guys here, who actually hit the reference range, might get quite poor z-scores. Because they're actually quite off from the consensus value. At the same time, they actually have very good results. Then here is the next one. This is now something that we also organized several intercomparisons, another field, which is dissolved oxygen in water. I think I've mentioned, well, most of you know explicitly well from the winter school that Irja Helm, the person with whom you do the lab, or who manages all the lab things, her specific area of expertise is dissolved oxygen concentration in water. And here you can see interlaboratory comparison measurement. And this is an interesting one. It's the in situ intercomparison, meaning oxygen samples are not sent around, but people bring their instruments together. It was carried out here in Chemicum in 2012. And here inside is the sample. Those of you who were in winter school, you actually recognize pretty well what is going on here. Yeah, you went through something very, very similar. And here now you see how the participants have obtained results and how they have evaluated their uncertainty. The reference value is 12.74, so it's saturated value at 5 degrees centigrade. Yeah, pretty high level of oxygen. You see that some of them are actually quite good in terms of the value. So that, for example, let's say, we could say that all these labs did pretty well. This one also. And also put this lab here. Yeah. So all these labs, measurement-wise, did more or less okay. But as you see, some of them have, actually most of them, are massively underestimating their uncertainty. So these EN scores above 1 are caused explicitly by the fact that they have underestimated the uncertainty. And then what you also notice is that some are completely off and yet have very good like confidence in that, that their uncertainties are very low. So these people don't really know very well how to measure, but they also don't know how to evaluate uncertainty. So that EN numbers really tell very well who is who. These people should really take care of their uncertainty estimation and also perhaps measurement abilities. But if we calculate the z-scores for all these, they are all below 2. So they were all walking, I mean, z-score-wise, they were all walking home very happy with themselves. Oh, we passed, we did very well. Yeah, z-score below 2. I mean, absolute value is below. But of course, in this report you can download if you wish. That report presents both ENs and Z-scores. So that if a creditor comes and asks that report and lab hands on, the creditor opens, and sees the EN number, then lab is not so happy. Report was done in such a way that both. So this gives some idea that these things, although they both try to evaluate the goodness of the lab, but they do it like differently. And Z-scores, in many cases, especially if there are so many scattered laboratories, Z-scores are very lab-friendly, let's put it that way. So that if the scatter of the results is big, then the target standard deviation is big. Target standard deviation sitting in denominator, meaning big target standard deviation, small z. So that this gives some idea that if scatter of labs is big, then z-score might be too. There's a word in Estonian which is leebe, but I don't know how to say it. Too accommodating, too welcoming, or too, let's say, too friendly. It gives like too good opinion of the laboratory. Okay, the next one is even more familiar for many of you, but that we will leave for Friday. So on Friday, we will start from here. And we will revisit the intercomparison that you did in winter school. I mean, the majority of you, those of you who are in each program, and I will give some more comments about it. But for now, if you have questions, please ask. Yeah, Andy, take microphone.
Value achieved, like slide.
Here.
Yeah. Or
the same way as in winter school, IRIA measured it with the Winkler titration.
But like, why we assume like
Yeah, this titration method that IRIA uses has been validated against other similar titrations. Its uncertainty sources have all been carefully investigated. Actually, I think you remember from the winter school, and also I think I showed you, also in this course, I showed this huge formula covering the whole slide and explained the uncertainty. So IRIA has made huge work. As I explained, I think it was part of her PhD thesis. Yeah, her PhD thesis, the whole PhD thesis, essentially focused only on this one thing. Yeah. So if you remember, our uncertainty estimation was sometimes that, okay, yeah, this is expert estimate. Yeah, we think this is not more than 2%. But IRIA didn't do anything. She really measured all those uncertainties, how much it gives. So that there's good reason to be confident that this is a good value. And there's one more thing that is important here. Specifically here, this is saturation value, but dissolved oxygen concentration in water, if temperature is fixed under saturation conditions, are also known from literature. So IRIA is not the only person who has measured those things. That can also be, has also been measured by others. And the saturation value also matches very well if IRIA does these Winkler titrations. So this is like an additional check that enables saying that her titrations are really good. Right, Tane?
This IRIA's result is not considered at all as a reference, consensus value. It's an independent. It could be considered an independent value, right?
This one here.
Exactly, yeah.
Yes, this is independent. Yeah, sure. This is why we calculate EN scores. Yeah.
Exactly, and the score, instead of like calculated a consensus value, could be like used with an independent value. The score estimation doesn't
like improve using like instead of the consensus value an independent value, or it will be always a wrong estimate, a misleading parameter to estimate.
So do I get it right? Your question is that, okay, we do have here independent reference value, yeah, but the z-scores we still can calculate against consensus value.
No, like this, you calculate this theta value here, all of them will be good. It will be a good parameter, even though the value are not good. But instead of like we're obtaining here the theta value with an independent value, and still it's a grown parameter to evaluate.
No, Maitane, these are not zeta scores. These are z-scores.
Sorry. So we are not using a consensus value. We are using an independent value.
I have to check. I think it was a consensus value of labs that was used. But yes, in principle, you can calculate z-scores also against the independent reference value, but still using the target standard deviation of the laboratory. Then this will be something like little bit like some kind of combined score or mixed score. No, it's not completely wrong at all. Yeah, you can do that. And those z-scores then would probably be less friendly to laboratories if they are systematically off, like systematically. Here we don't see big systematic effect, but the lab average seems to be lower than the reference value. If you look, most labs are below here, and one is actually far below, and only 3 are above the reference range. Did I answer?
Very fast questions. In the case that a lab is accredited, right? Could I present, like, if the inspector of the accreditation comes and asks me for my interlaboratory comparison, can I tell him my z-score, or should I report my ILC with N or zeta score?
Typically, if you participate in such intercomparison where both of these are given, then it's not just that you present one number, you discuss with the person. You show, okay, look, these are the results, yeah. See, in z-scores we are doing fine, yeah, but look, sadly our EN score is not really good, yeah. The reasons are this and this, and we are trying to improve. So, for example, if it's this laboratory, then the laboratory can tell the accreditor that, look, yeah, our z-score is very good, yeah, we're actually not so much off, but we obviously need to work with our uncertainty evaluation. Yeah? So this is our bottleneck, this is our drawback. So yes, we are working on our uncertainty evaluation and hope to get better.
Okay, but I still keep the process kind
of
discussion.
I think, you see, in this case, if those labs now go back and show this report to their accreditors, then if they are not all from Estonia, but most are from Estonia, then with very high likelihood, they will not have big problems. Because the z-scores are fine, so we see that they are, then the accreditor should like remove accreditation for a number of them. That would probably not be okay, but they will get some kind of, let's say, either warning or some kind of like obligation. Okay, you need to revalidate your method, yeah, so this person really needs to do more work, yeah, but this person needs to find out how to calculate uncertainty correctly, so it will be realistic uncertainty. So I don't think any of these labs here, except maybe this one, this is really catastrophically off. Any others here would have any, like, I mean, big problems with the accreditor. Yes, they will get some like notice that yes, okay, yeah, try to improve, yeah, not so good, yeah, you've done, but yeah, not that bad. And again, as I also explained yesterday, it's not common to single-handedly and easily suspend accreditation of a laboratory, because as I explained, this has catastrophic consequences for labs which operate in such legal environment where accreditation. Well, because overnight they will lose all their customers, lose all the income. They still have staff whom needs to be paid salaries and so on. So everybody understands that. And then the reason why, this is the reason why accreditors are not very harsh. And it makes sense because otherwise it would introduce very strong incentive to really fraudulent behavior, which absolutely they want to avoid. So they are quite, accreditors, at least here in Estonia, quite okay with honest mistakes. But with fraud, they are not okay. If they catch you from fraud, they can really suspend accreditation immediately. But if it's honest mistake, they usually, okay, you improve, yeah, present me your plan, how you plan to improve, okay. You are sending this person to this training, okay, you are buying new instrument, okay, you are buying a new thermostat for better calibration, okay, fine, yeah, you did all these things. Please then go and participate again, and next year when we will come again to visit you, you present us new intercomparison results. Let's see how it is. Okay, any other questions? Apparently not. Thank you.